Hello, my name is John Capobianco and I'm a product marketing evangelist for Selector AI, and this is really exciting stuff. We've heard all of the hype about AI agents and how AI agents are going to dominate 2025. I've even made some predictions about this. If you've been watching my progress, I've been working on AI agents for a few different systems, including Netbox and a few others. Today I'm going to show you from top to bottom a working AI agent that is free, local, private, and confidential using Ollama and the Command-R7B small language model from Cohere. Now, what is an AI agent? An AI agent is an LLM, and we're tapping into its reasoning capability and its ability to take action and to do tool calling, as it's known. And the command model supports tool calling. So we can write little discrete tools, tiny little tools in Python, and literally give access to the LLM so that it can autonomously invoke these tools and combine it with generative text to perform CRUD activities: create, read, update, delete. Now in this video, we're going to be fully operating a network device, a Cisco IOS XE router in the cloud. My AI agent is literally going to perform the tasks a network engineer would perform. I know that sounds scary, and I know it sounds exciting, and I know it sounds like there's a lot of opportunity here, and there's a lot of caution and danger here. This agent could technically replace network engineers with more time and more polish. However, we're going to do full CRUD activities today with nothing more than AI agents. This is not retrieval augmented generation. There is no vector store, there is no embeddings, there is no conversational retrieval chain, there's no semantic search. This is purely the agent running code, taking the output, and turning it into natural language. By the way, we're going to drive this with nothing but natural language. Can you do this? Could you please do this? Could you tell me that? And it's going to do it all through the reasoning and action. So please share this video. Please make sure you turn this on to anyone you know who's related to technology. I say this because I haven't seen a lot of agents in action. I've heard a lot of talk and I've seen a lot of hype, and I wanted to try to build one that had purpose and meaning and could be a meaningful tool. And I've managed to do that. So let's take a closer look at the code and the infrastructure surrounding the code. So first, we're going to have a user that asks a question, gives a set of instructions, provides some direction, interacts with one of two containers. I have a container that's going to be my AI agent code, which is a Streamlit front end, and this is listening on 8501. See if I can update that. Right, this is Streamlit 8501, which has access to the Ollama container on 11434 with an API of /API/generate. I'm going to use a Docker Compose file to bring these two containers up together and a couple of little bash scripts to get them started. Now, if we blow up the agent code, this is going to be an Ubuntu image with Python 3, and the environment is going to have SSH, pyATS full, Streamlit, LangChain and LangChain community, and Ollama. It's also going to have a testbed file for network connectivity and a pyATS JSON list of valid commands. Now, what do I mean by that? So if I do show IP interface brief here, there is a valid parser for Cisco IOS XE that will return this structure of JavaScript object notation. Right, so we have all of these parsers, and I've taken all of them. There's about 4,000, 4,400, something like that, literally thousands. Every supported pyATS command, we're going to put it in a JSON file, and our agent is going to have access to it. Now, here's what's going to practically happen. the question's going to come in. Let me see if I can annotate this in green. So the question comes in, and the agent's going to say, is there a supported command in the JSON file? Do a JSON lookup if it's a read activity. And if it's a read activity, get the right command to invoke the right parser. Now this is all done iteratively here. So the agent is talking to Ollama, and Ollama is giving instructions back to the agent in this infinite loop. So let's look at the code. And I've blown the screen up so we can take a look. So I have two Docker files, one for my Ollama environment, which is just from Ollama and pulls down the container from Ollama. And I have an entry point of this initialization script that's going to go ahead and start the Ollama server and pull the command R7B small language model. My container for my agent system is going to be Ubuntu based with all of the tools I need, including SSH and pyATS, LangChain Community, Streamlit, and Ollama, and start with this startup script that does the Streamlit run command to start the Streamlit application. I have this Docker compose file that brings up my two services on the same network on the ports that I've described. My Ollama image has access to my GPU here. So that is the connection to my RTX 2060, a little RTX 2060. Now let's go through the code. And the most important thing is this template. So this template gives all of the instructions that we need, how to use the tools, the list of tools, the tool names, and this is the key. The format of the React agent, the thought, do I need to use a tool? The action to take, which should be one of the tools. Action input, the input to the action. An observation, the result of that action. And then the final answer back to the user. We have some examples here so that we can kind of help this agent system. And finally, we have to tell it to begin. All right, now what are these tools? So I have a show command, and it basically is, right, load the pyATS testbed, connect to the device, and then run and parse a particular command that's going to be passed in by the LLM. The LLM is going to complete this function. We decorate that as a tool here and pass that along to the toolkit that the AI has access to. And I have several tools: how to execute a show command, how to do show run, how to do show logging, how to apply device configuration with the .configure command. Okay, and one of my examples in that template shows how to call a configuration, right, with action input of the command that we want to apply. Nothing is hard-coded. Everything is dynamically driven by that text and by that human instruction, that prompt, if you will. So let's do Docker compose up. And we're going to see two containers come up. One is listening on 8501, my front end. And then I have Ollama in the back end that's downloaded the 5.1 gig model. The Commander 7 billion parameter model has been downloaded. All right, so everything's all ready to go here. I have a couple deprecation warnings. I'll deal with those later. Okay, so let's start asking some factual read activity questions. So I'm going to sign in here to this always on sandbox. Make sure I get the credentials right. And here we go. So let's do a show IP in brief. And we see that GI1 has an IP address. So we're going to ask, what is the IP address of Gigabit Ethernet 1? Now what's going to happen is you can see it loading. Let's maximize this. We can see it loading the 8.03 billion parameter into my GPU at 4.7 gigs. And somewhere in here, it's going to indicate that it's the RTX 2060. Now here we go. Check this out. So we hit the API generate API on Ollama, and then an agent executor chain gets executed. So it's actually the Ollama triggering this agent executor chain. Do I need to use a tool? Yes. So it wants to run show IP interface brief, and it first checks and sees if that's a supported command. The very next thing it does, action, run the show command tool with the input of show IP interface brief. Here, loading testbed, connecting to device. I'm on the router now. The AI agent is doing all of this work. There's the show IP interface brief command. It hits the generate API to give us back human text, and I bet if we check the answer, it is correct. 10, 10, 20, 48. Now let's do another read activity. What is my default route? How about what is my default route? Now if I do a show IP route, we can see my default route is 10, 10, 20, 254 via GI1. All right, let's see what happens here. API generate, it runs the command, picks the right tool, runs show IP route, and now it should have the routing table as JSON, and we should get back an answer. Hey, there we go. So your default route in this network is all 0/0, correct, has a next hop of 10, 10, 20, 254, correct, via GI1, also correct. So we've done two read activities. Let's do an update. So let's do show IP in brief. And we'll see that if we do a show run in GI2, let's change this description. All right, so right now the description is configured by netconf. All right, so now let's try a update activity. Can you please update the description of Gigabit Ethernet 2 to configured by AI agent? All right, so let's. Okay, so here's the logs. Agent executor chain. Do I need to use a tool? Now this is a little goofy, and I might fix this to tell it if it's a configuration, don't check the supported commands. Anyway, it does move on to the apply configuration tool with the input of multi-line interface GI2 description configured by AI agent. Loads the testbed, connects to the device. Hang on, check this out. It goes into config T, interface GI2, description configured by AI agent, end. Success, configuration applied successfully. Now it looks like it did it a second time, which is okay, that's fine. But if we look here, quiet. If we look here in the logs, we can see configuration has been successfully applied. Now, here is the previous configuration, configured by netconf, configured by AI agent. We've just done an update. So we've done read and update. Now we need to do a create and delete. Now let's do something like network related. What we can do is let's try to add something like this. So please update can you please configure GI2 with an IP address of 192.168.100.100/24. Let's give it CEDAR, because when you configure it, you can't use just /24. Let's see if the AI can interpret that and enable the port. So we're going to hit send, and just to show you that this isn't, staged or anything, let's reconnect to the device. show run in GI2, it has no IP and it's shut down. So let's go ahead and see. Here's the tools with an input of the full IP address and no shutdown. Now what we should see is some, right? So it's applying configuration. And here's the configuration. And we should have an answer back now. Configuration has been applied successfully to GI2 with an IP of this and a port enabled. So let's take a look. Ha! It is now enabled. It's up and it has an IP address. Show in, right? GI2 has an IP and it is up. Pretty cool, right? So let's do something else. Let's do this in loopback 100. Description to be deleted by AI. No shut. IP address 172.16.100.100. Okay, so we have loopback 100. Let's see if we can delete this to finish off the CRUD activities. So can you please delete interface loopback 100? Let's try this again. There we go. No interface loopback 100. Applying config. No interface loopback 100. It should come back to us now and say that it's been removed. Configuration has been successfully applied. And if I check here again, there is no loopback 100. All right, I'm going to stop the server and start the server one more time. And let's try to add something a little bit more intense. Let's see if it can add a route. Okay, so we've done all the CRUD activities and I'm pleased with that. Let's go ahead and see. Can you please add a route to 172.16.100.100 using interface gigabit Ethernet 2 as the outgoing interface. Going to using GI2 as the outgoing interface. Let's just see if that will work. And if I show you the routing table, show IP route, there's no routes to 172.16. And if I do a show run, include route, did I just create that now? I just created it now. There's the route. So it's able to create routes. It's able to update interfaces. It's able to delete loopbacks, create loopbacks. Basically act as a junior network engineer. So now if I check the routing table, there's that route via GI2. And there's the answer. Although it hallucinated here and doesn't realize that it did work. Anyhow, like I said, it's early, but we've done all CRUD activities. We've done some pretty intense networking work. Let's come back to the main screen. Pretty remarkable. Now, I'm not saying that it's perfect, but keep a few things in mind. A local RTX 2060, a quite old, barely capable graphics card. A 7 billion parameter model, free and local in Ollama, and tool calling from this model that was just released days ago. So all of this is very bleeding edge and very new and a little buggy. I'm not going to claim that it's not a little buggy at this point. However, if I had a more capable system, I would run a much more capable model, Cohere's 70 billion parameter model or something. Also, I could pay for cloud services with ChatGPT or something, and I would have no problems. Everything would work just fine. This is to try to show you that even on low-end computers, locally and for free and confidential and privately, we can make AI agents. All of this code is going to be on my GitHub repository. I'll put the link in the comments. Make sure you check it out. And I don't know what to say. There's a lot to think about here. The implications to the field of network engineering, the implications to human resources, the implications as to how long the longevity of the network engineering discipline, given the capabilities of AI agents and artificial intelligence and generative AI and LLMs and on and on and on. I feel like I'm looking into the future, a glimpse of the future here. And I know I've seen technologies become obsolete and entire disciplines become obsolete. In the early 2000s, it was voice over IP that completely eliminated the PBX, the old twisted pair POTS, plain old telephone systems, right? So that's gone. Everything's voice over IP now. There's other disciplines, other technologies, analog to digital. Well, now we're going from digital to artificial. We're moving from digital to artificial, and it's going to have drastic implications. So the best I would say is to try to get involved early, try to understand this, try to make your own agents, and try to be as best prepared as you can for a radically changing future.